Okay, I want to go over this problem here, the one that says number 8. Calcium oxide and water react in an exothermic reaction. And this reaction reads 1 mole of calcium oxide and 1 mole of water turns into 1 mole calcium hydroxide, and delta H is negative 64.8 kilojoules per mole. Negative again, exothermic. So, and it also says it's exothermic. Question, how much heat is liberated when 7.15 grams of calcium oxide solid is dropped into a beaker containing, there used to be a number here, I just changed it to excess amount of water. I didn't want to make it into limiting or excess reagents problem. If there were a number, technically you have to figure out which substance runs out first, which one is the limiting reagent, excess reagent. I'm just saying this is excess, therefore calcium oxide is limiting. But that's not the point. Point is, if you had 7.5 grams of calcium oxide, you put it in plenty of water, how much heat will be given off? Remember, I know from this balance equation that 1 mole of calcium oxide, 1 mole of calcium oxide, that's there, coefficient is 1, gives off 64.8 kilojoules of heat. And I get that right there. It's given. Negative, I'm not going to write the negative sign in, but negative, again, exothermic. It gives off heat. This question says, well, what am I given? I'm given 7.15 grams of calcium oxide. That's my given. Let me start that. 7.15 grams of calcium oxide. I want to know how much heat is given off in kilojoules. Well, if this is moles of calcium oxide, that's easy because 1 mole of calcium oxide is 64 kilojoules of heat. So if this was moles, it would be 7.15 times 64. But this is not moles. This is grams. So first thing we need to do, change grams to moles. That's why we did the review on what is molar mass, or how to change grams to moles, moles to grams. First thing I defined is the molar mass of calcium oxide. So the molar mass of calcium oxide will be whatever calcium is on the periodic table, whatever oxygen is on the periodic table. And on the periodic table, calcium is 40.08. Oxygen on the periodic table is 16. Add that up, and that is 56.08 grams. Okay, a little bit off the screen, but 56.08 grams of calcium oxide. So now I can change grams to moles, and then moles to kilojoules of heat. Question is, how much heat is given off when 7.15 grams of calcium oxide is dropped in a beaker? So first step, change grams of calcium oxide into moles. And I know there are 56.08 grams of calcium oxide in a mole. That's what I just calculated. So grams will cancel out. Grams and grams cancel out. Now I have moles. I'm not trying to find moles. I'm trying to find how much heat in kilojoules. Well, I also know that 1 mole of calcium oxide is 64.8 kilojoules of heat. 64.8 kilojoules of heat. Moles and moles cancel out. So now we have kilojoules. It'll be 7.15 divided by 56.08 times 64.8. And what is the answer? Well, I don't know. Let me grab my calculator. So that was 7.15 divided by 56.08 times 64.8. And on my calculator, I got 8.26. 8.26 kilojoules of heat. And, or in other words, this is multiple choice, this one would be B. Okay, so this was another one of these kind of thermochemical stoichiometry problems. I want to do another type. Move this for a second. Do another type of problem. By the way, this all comes from the normal, if we're in session, we met. we would have done these problems because this would be a Chapter 6 practice test during normal school that I would have assigned this as homework anyways. But obviously, we're just doing this via, well, internet. But so we are actually doing the same overall material, just being taught in a different way. I'm not going to go over number 1. I'm going to do number 2. You should know what endothermic means. Just in case you did not know that one, number 1, yes, the answer is, well, actually, maybe I should ask you that. What is the answer for question number 1? An endothermic reaction causes surroundings to, decrease in temperature. Exothermic warms up the surroundings, and endothermic makes it colder or decrease in temperature. Okay, that's not the question I want to do right now. I want to do number 2. Question number 2 on this Chapter 6 practice test says, if 325 grams of water at 4.2 degrees Celsius absorbs, 12.28 kilojoules of heat, what is the final temperature of water? The specific heat of water is 4.184 joules per gram Celsius. Okay, I want to write down some of the givens here. I'll write it here because I have a little more room. The mass of the water is 325 grams. I know the specific heat of the water is 4.184 joules per gram Celsius. That was given. Also know the water is at, okay, so the initial temperature is 4.2 degrees Celsius. And it absorbs the amount of energy, heat, Q, is 12.28 kilojoules. Okay. There's one thing I want to change first of all. Notice my specific heat's in joules and my heat is in kilojoules. So those are two different things. It's like you're trying to add grams and kilograms. You either change your kilograms to grams or grams to kilograms or whatever. They have to be the same units. So I'm going to just change this now. That's the same as 12,280 joules. Why? Kilo. Kilo means 1,000. If this is kilograms, if it was 12.28 kilograms, you're trying to change it to grams, it would be multiplied by 1,000. So 12.28 times 1,000, 12,280 joules. Okay, we're trying to find a final temperature. What's the equation here? The equation we're going to use is Q, that's a Q, equals ms delta T, the specific heat equation. Well, delta T, maybe I should write that, is final temperature minus initial temperature. So, okay, so now we can do this problem. We know that, I'm just start plugging in. Q is 12,280 joules. Actually, I'm gonna change this. I'm trying to find the question's final, what's the final temperature? Maybe I'll just leave it in as delta T is final temperature minus initial temperature. Delta T is final temperature minus initial temperature. Why don't I now plug it in? I want to maybe just leave it this way. 12,280 joules. The mass is equal to, where's the mass? 325 grams. Specific heat is 4.184 joules per gram Celsius. Final temperature, I don't know, that's what I'm trying to find. The initial temperature, 4.2 degrees Celsius. Okay, I could probably just left out the units of this thing, but because the only thing that will be left are Celsius anyways. So we'll divide both sides by 325 and 4.184, and I'll have, so I would have TF minus 4.2 is equal to whatever 12,280, whatever, let me move this paper up, whatever, 12 to 80 divided by 325, and 4.184 is 9.03. Okay, so it's really like 9.03 is equal to x minus 4.2. This is just an algebra problem now. Okay, now it's just purely algebra. Add 4.2 to both sides, and TF, I don't want to think, 13.2. Or D. Okay, so this also makes sense that first of all, it goes up in case, well, yeah, I was just looking at your other choices. Okay, good. None of them were less than 4.2 because of absorbed heat. Of course, temperature should go up. Okay. Okay, so we're going to stop here for this, but these are some types of problems that we would be doing even in regular session. Okay, so that's it for now.